right? We would have to gather enough evidence to say that it was a square. So, for example, what would be enough evidence to show that a quadrilateral was a square? What's like the two defining features of a square? So all four sides are equal and 490-degree angles. Good. So if we had both of those, that would be enough to say that it's a square. All right. Now, of course. Now, that's what sufficient conditions talks about. So that's that first graphic organizer. It's just to get you thinking about whether we have enough information to say that something is a specific type of quadrilateral. All right. So let's just look at this. This should be pretty quick. All right. So, which of the following would not be sufficient to show that a quadrilateral is a square? So, we want to show that a quadrilateral is a square. So, the first is it has four right angles and congruent adjacent sides. The second is it's a rhombus with a right angle. The third, its diagonals are perpendicular and bisect each other. 4, it is a parallelogram with perpendicular diagonals that are congruent. All right. So look at your journal entry. Think about it. I want you to think about which of those answer choice would not be enough to show that it's a square. So 3 of them is enough, but 1 of them is not enough. So think about it. All right, so we're going to do a show of fingers of what answer choice you think it is. All right. So on the count of 3, raise the one that you think it would be. 1, 2, 3. Okay, so I see a lot of 2s. I see a 1. So that's what I thought. Okay. So let's just do, 2 is actually incorrect. It is enough. So let's talk it through. So if we have a quadrilateral with 4 right angles and 4 congruent adjacent sides, what did I say adjacent means? Next to each other. So let's say that I had a quadrilateral and I knew it had 4 right angles and congruent adjacent sides. So those 2 are congruent. Those 2 are congruent. All right. Is that enough? That's enough. All right. Because if the adjacent sides are congruent, then the opposite sides also have to be congruent. So that's enough. Oops. So that's eliminated. It's a rhombus with a right angle. What's true about a rhombus? So what's true about a rhombus? It has 4 congruent sides. Now, it has a right angle. So let me ask you guys this. If it has 1 right angle, what does that mean for the other 4 angles? They also have to be right because remember, all of the consecutive angles are supplementary. So if one angle is 90, that means all 4 got to be 90. So is that a square? Is that a square? Yeah. So that's not it. Its diagonals are perpendicular and they bisect each other. So we know that a square's diagonals are perpendicular. We know that a square's diagonals also bisect each other because that's what a parallelogram does. So the bisect comes from a parallelogram. Where does the perpendicular come from? The perpendicular comes from the rhombus. Now let me ask you this. Is that enough information to show that it's a square? If we just base it off the diagonals alone, we don't know anything else about the sides. No. Why? Because what else do a square's diagonals have to be? There's three things that go along with a square's diagonals. They bisect each other, they're perpendicular, and there was one other thing. I'll give you a hint. They share it with rectangles. They're congruent. So if we only know they're perpendicular and bisect each other, it's not enough information to say it's a square. It's enough for a rhombus. But remember, not every square is a rhombus. No, that's a lie. Not every rhombus is a square. All right, every square is a rhombus, but not every rhombus is a square. So unless we get a 90-degree angle in there, or we figured out that the diagonals were congruent, we don't have enough information to say it's a square. And then the last one, a parallelogram with perpendicular diagonals that are congruent. That's obviously enough to prove a square because that describes their diagonals perfectly. Does that make sense? Like what it means by sufficient conditions? Yes, no, maybe. All right. Let's look at these. So in the diagram below, which set of information would not be enough to prove the quadrilateral is a parallelogram? So let's go through these together. Now, I'm going to do a lot of marking and erasing, okay? So you may not want to mark until we go through it together, okay? So the first thing that they said is JM is congruent to KL. So these two sides are congruent. And JK is congruent to ML. So these two sides are congruent. Based off of what we know of a parallelogram, is that enough information to say it's a parallelogram? Yes, no, maybe, whatever. What do you guys think? Yeah, that's enough to show a parallelogram. So that's out. If you have two sets of opposite sides that are congruent, that's enough for a parallelogram. Then it says if JM is parallel to KL and JK is parallel to ML, is that enough to show it's a parallelogram? Yes, why? Not congruent. We have two sets of, not adjacent. Opposite sides are parallel. You have two sets of opposite sides that are parallel. Remember, that's what distinguishes a parallelogram from a trapezoid. Now, the third one, JM is congruent to KL and JM is parallel to KL. What do you guys think? It actually is enough because think about it. If these are parallel to each other and they're the same length, doesn't that mean that these would end up having to be the same length? Because if you think distance-wise, they would be the same distance apart. You following my drift on that one? Does that make sense? Kind of, sort of, maybe? So think about it. Let's say that I had, so look over here. Look at me. Let's say I had these two popsicle sticks. They're parallel to each other. Mm-hmm. All right. If I turn them, could I say that the distance between these two, the ends of the two popsicle sticks, is the same length? Yeah, I could. That's why that works. All right. Because if they're the exact same length and they're parallel, meaning they'll never intersect at any point, we can assume that any point on the line, if we intersected them or drew a line between the points, they would be the same length. So that's enough. And then the last one, JK is congruent to ML and JM is parallel to KL. Is that enough? It's actually not. All right, because think about it. Let's think about a trapezoid here. All right. What type of trapezoid has two congruent sides and two parallel? Oh, sorry. What type of trapezoid has two congruent sides and parallel lines. So this is a trapezoid, same conditions. What is that? It's an isosceles trapezoid. So that's not enough information to prove a parallelogram because these could be curved in towards each other. They could intersect at some point. We don't know. All right. We could say that it's an isosceles trapezoid, but without knowing that the other side is parallel or that the other sides are congruent, we wouldn't be able to know. So that's this one. Is this making sense to you guys? Like why they work and why they don't work? It doesn't make sense? Okay. Let's talk about it. Okay. So let's do this. I have these two magnets, exactly the same length. All right. I'm going to line them up perfectly with these two lines. All right. So they'll be parallel to each other. All right. Now, just because they're parallel, all right, even though they're congruent, all right, let's say that they weren't. So let's say that I shifted it or folded it. All right. They're not congruent anymore. Now, I know that the two sides are congruent. So if I connect them, so here and here. Just imagine that those are the same length. The lines are parallel. The sides are congruent. So does that make a parallelogram? Does this look like a parallelogram? So look, the sides right here and the sides right here. Does that look like a parallelogram? No. That's why it doesn't work. All right? Because just because they're parallel does not mean that they're the same length. All right? That's why we can show that if the same two sides are both congruent and parallel, that means that if we connected them, so here and here, that's clearly a parallelogram. All right? Does that make a bit more sense? So essentially, if you want to prove a parallelogram, you need one of three things. You either need, at least when it comes with sides, you either need to show that the opposite sides, both sets of opposite sides are congruent. You either need to show that both sets of opposite sides are parallel, or you need to show that one set of opposite sides are both congruent and parallel. All right, that's how you can prove a parallelogram. Does that make more sense? Okay, good. All right, it is known that a quadrilateral WXYZ diagonals WY and XZ are perpendicular and WX is congruent to XY. And it's asking, is this sufficient to prove that the quadrilateral is a rhombus? So let's draw our quadrilateral. Now remember, it's not going to be drawn to scale, but I have a quadrilateral WXYZ. And they said that the diagonals WY and ZX are perpendicular. And they also said that WX is congruent to XY. So Here's my question. Is that enough to say that that's a rhombus? So just given what we know, which is what I marked, is that enough to say that that's a rhombus? So I want you guys to take a minute, think logically about it, and tell me what you think. Talk amongst your group mates, but I want you guys to figure it out. What do you think? So look at your foldable. That may help. And again, think about other shapes that may look like that may have perpendicular diagonals and congruent adjacent sides. We don't know that. They didn't tell us that. So if those two are, but as it stands right now, we don't know that those two are congruent. All right, guys, what do you think? Yes or no? I heard some no's in there. Who said no? Well, who said no? I just want to know. I just want to know reasoning. So those who said yes, why do you say yes? But I didn't draw it to scale. I could have drawn it like this. Diagonals are perpendicular. Those two are the same. Is that a rhombus? That's a kite. So my question is, based off of what they gave us, do we have enough information to say that's a rhombus? No, we don't. Like I said, you cannot take anything at eye level. Remember, so pretend that you're in court, okay? Pretend that you're trying to prove a murder trial, okay? You know that if you're trying to prove murder, you have to have solid, non-negotiable, clear evidence, okay? There can be no way around, no loopholes, nothing. It is completely, absolutely, positively sure that that guy murdered this guy. Same thing with proofs. You have to have exactly enough evidence, so without a doubt, it's a rhombus. And every condition will be met. Yes? And then isn't that the same as like if you see a ship that looks like a rhombus, then it's still a rhombus? Nope. Because if you see a murder, that's just witnessing. And that's evidence. All right, that's part of the evidence. But like let's say that it was a murder, we had no idea who did it. Right? No one saw it. It was like one of those serial killers went bump in the night. You know. Okay. Anyway. So anyway, let's say no one saw anything. All right. They just found the body up in the woods somewhere. Okay. They want to figure out who it is. So they gather things like fingerprints. They gather things like, fibers and samples and everything else. So they know exactly for a fact, or they look for a murder weapon. They try to find all of these things in order to prove that someone is guilty or to prove that something happened. Here, it's the same thing. We got to gather enough evidence to prove without a doubt that that's a rhombus. As it stands right now, we just have enough to say that's a kite. All right? Because a kite, remember, a kite shares perpendicular diagonals like a rhombus does, and it has two sets of congruent adjacent sides. Whereas a rhombus, it showed that only one set of the adjacent sides were congruent. Now, let's say that they said it was a parallelogram and these sides were congruent. That would be enough because we know parallelograms' opposite sides are congruent. But they said quadrilateral. So nothing applies right now. We have to take it at face value. All right. Does that make sense? Bit better? That's why I say proofs are hard. It's a pain in the butt. So no, because it could be a kite. All right. Not enough info. So 4. In quadrilateral ABCD, angle A and angle B are both right angles. Draw a label that illustrates this is not sufficient to prove that ABCD is a rectangle. So, let's say we had some shape. All right. Now, I'm drawing it to look like a rectangle. All right. But remember, we're assuming some things. Okay. All I know is if I have some quadrilateral ABCD, and they just said these two angles were right angles, and that's it. Why is that not enough information to say that it's a rectangle? No. Because a square is a rectangle. Let me ask you this. Could you draw another shape that has two consecutive right angles that doesn't look like a rectangle? What would that look like? Squares are rectangles. Who wants to draw? See if they can do it. Dominic, go for it. Just on my thingy. Just don't hit the button. There you go. Good. That's a trapezoid. So if I drew it, these are right angles. A, B, C, D. So now, if the opposite angles were 90 degrees, that would be enough to say it's a parallelogram. No, that's definitely a trapezoid. Here, I'll draw it the other way. Here, I'll draw it the other way. That work? Trapezoid. So, guys, what I'm saying is, I could draw it this way. So that lines up with how I drew it. Still trapezoid. No matter how you draw it. Now, again, why can I not say it's a rectangle? What am I missing? The two other 90-degree angles, yes. But also, what else? What else is like a key feature of a rectangle? The opposite sides are congruent. So if we knew that at least one set of opposite sides were congruent, or both sets of opposite sides were congruent, or if we knew that rectangle, that it was a parallelogram. If we knew that the quadrilateral was a parallelogram, that would be enough to say it's a rectangle, but we don't. So the reason it's not enough information is because we need to show either opposite sides or two sets of opposite sides are congruent or parallel. Up. So guys, that's the thing with proofs. We want our brains to think just because I drew the picture to look a certain way doesn't mean it's true. I just drew a picture. All right. But there's other ways you can draw said picture because we didn't have enough information. All right. That's the difference between making assumptions and stating a fact. All right. The assumption was when I first drew that picture, I drew like a rectangle. But if I did it I had 4 other ways I could draw that shape. All right. So, and it still fits the fact that it's a quadrilateral with 2 90-degree angles. All right. Now, so with this shape, they drew A, B, C, D for us. They marked 2 angles as congruent. So both sets of opposite angles are congruent, and they marked that the 2 adjacent sides are parallel. What shape would you call this? So we could say it's a parallelogram because it's so look at the base level we could say it's a parallelogram, but there's one thing that makes this a rhombus. It's the 2 congruent adjacent sides. So what makes this a rhombus? So remember, rhombuses are parallelograms. Okay? So if it helps, let's think back to that flow chart that we made. You guys remember this flow chart that we made last week? So we have the quadrilaterals. From quadrilaterals, we have the trapezoids and the kites. Trapezoids can turn to isosceles trapezoids. Isosceles trapezoids can turn to a parallelogram, which can break apart into a rectangle and a rhombus. And remember, they had the incestuous relationship and made a square. Now, there's one other connection that I didn't tell you. You can actually connect a kite to a rhombus. All right, because of the fact that they have perpendicular diagonals and 2 sets of corresponding congruent sides. So update your picture in your journal, just draw that one arrow. But if you look at this, remember what I said. If you look at one shape, let's say rhombus, any shape above it in the flow chart are the features that it shares with the rhombus. So in other words, all the features in a parallelogram are in a rhombus. So opposite sides are congruent. That if they didn't show us that these 2 sides were congruent, we just had the opposite angles. That's enough to say it's a parallelogram. What makes it a rhombus is that the adjacent sides are congruent. All right? Because if you think about it, in a kite, it only has 1 set of opposite congruent angles. A parallelogram has 2. All right? But a kite has a pair of adjacent sides that are congruent. A parallelogram does not. Thus, since we have both happening at the same time, they create the baby of the rhombus. All right? Does that make sense? So this is without a doubt a rhombus. Now, okay, 6 is more about slopes and distances. That's more coordinate geometry. But, okay, let's put it this way. Okay, so these are slopes. All right. So these are all slopes. So they're saying that PQRS is a quadrilateral with each of the following. And so they gave us these slopes. All right. Now, let's just say that I drew any quadrilateral, so I'm not even going to make it look like anything. I'm going to call it PQRS. Now, they said P to Q has a rise over run of 3/7. QR has a rise over run of -7/3. RS has a rise over run of 3/7. And SP has a rise over run of -7/3. And again, these are slopes. Shh, stop talking. These are slopes. Meaning you would go up 3/7 or down 7/3. All right? Rise over run. That's what it's talking about. Now, think back to math 1. If the slopes are the same, that means that those lines are what? Parallel. So that means that these two lines are parallel and these two lines are parallel. Even though I didn't draw them to look like that, we have enough information to say they are. So at the very least, this can be a what? Not a rectangle. From what I said right now. Now, the correct answer is rectangle, just from what I said, the parallel. But there's a reason why it's a rectangle. But from just knowing that the opposite sides are parallel and nothing else, we can say it's a what? A parallelogram. So as of right now, we can say it's a parallelogram. But what makes this a rectangle? So we know this is currently a parallelogram. So this is currently a parallelogram. That's all we know. It's a parallelogram because of the why? Because two sets, opposite parallel sides. That's it. But what makes it a rectangle? The correct answer is a rectangle. How do we know they're right? Right. So remember, perpendicular slopes are opposite reciprocals of themselves, meaning if you flip them over and change the sign, they're perpendicular. So on top of that, these are rectangles. These are 90-degree angles. So we can finally say that it's a rectangle because we have 4 right angles from perpendicular slopes. So remember, that's opposite reciprocals. So if the slopes are opposite reciprocals, that means they're perpendicular. Ladies. All right. Shh. Now, let's say we went a step further. So as of right now, we know it's a rectangle. All right, we have the parallel sides and the 90-degree angles. All right, so P, Q, R, S. Now, it then says that PQ has a distance of the square root of 58, and QR has a distance of 2 square root 58. So here's my question. Does it stay a rectangle, or can we say it's a square? Why? Why? Right, the adjacent sides are not congruent. All right? Because square root of 58 and 2 times the square root of 58 are different numbers. So it stays a rectangle. All right. Now, last one. Let's see if you guys can do it. Given the points A, B, C, D form a quadrilateral, A, B, C, D, determine which type of quadrilateral you can prove given the specific information. So, if we know for a fact all they gave us is that A, B, C, D is at least one set of parallel sides, what can I call that? So look at your foldable. If I have at least one set of parallel sides, what is the only quadrilateral that I could call it? Trapezoid. So as of right now, I can call ABCD a trapezoid. Now, let's say we added on another fact saying that the parallel sides from part A are also congruent. So if I have my figure, I have ABCD, and again, I'm not drawing it to scale. So let's say A, B, and DC were parallel, and then we also found out that they're congruent. What type of shape can I say it is now? So can we call it something else below a trapezoid? We can call it a parallelogram. Remember, if the same pair of opposite sides are both parallel and congruent, we have enough information to say it's a parallelogram. Now, let's go a step further and say that the diagonals, and this is not drawn to scale, but let's say the diagonals were perpendicular. What can we say it is now? A rhombus. So that's how proofs work. We started with a trapezoid, but as soon as we added on one more condition, it became a parallelogram. We add on another condition to that, it became a rhombus. Okay, that's how proofs work. We're adding enough evidence to make shapes. All right, so let's actually talk about proofs now. So that was just to get your mind thinking about it. Let's actually talk about it. So go to that other graphic organizer, the pink one. All right, so to prove a parallelogram, one must prove one of the following. So you either need to show that both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, one pair of opposite sides is both congruent and parallel, the diagonals bisect each other, or both pairs of opposite angles are congruent. If you prove one of those 5 conditions, if you have enough information to show one of those 5 conditions, you have a parallelogram. To show it's a rectangle, you can say it's if the quadrilateral is a parallelogram, so we already have enough to show that's a parallelogram with a right angle, it's a rectangle. If the quadrilateral is equal angular, meaning all 4 angles are congruent, it's a rectangle because it can only be 90. And if it's a parallelogram whose diagonals are congruent. So for a rectangle, you have to prove it's a parallelogram first. And then you can show that, okay, if it has a 90-degree angle, it's a parallelogram with a right angle. Rectangle, that's enough. Or a parallelogram with congruent diagonals, rectangle, that's enough. Rhombus has to be a parallelogram with 2 congruent consecutive sides or adjacent sides. So if it's a parallelogram with two adjacent sides that are congruent, it's a rhombus. If it's a parallelogram whose diagonals are perpendicular, rhombus. If it's just a quadrilateral that is equilateral, meaning all four sides are equal, rhombus. You don't even have to show it's a parallelogram. If it's a parallelogram and a diagonal bisects opposite angles, so it cuts those angles in half, rhombus. Square, there's only two ways to prove it. You either need to prove it's a rectangle first with two consecutive sides congruent, or you need to prove it's a rhombus with one right angle. So almost all of these proofs, you have to show it's a parallelogram first in some shape or form. And then you have to meet more conditions. All right. Now, there are two types of proofs. There's two column proofs and flow proofs. They're pretty much about the same. Okay. Usually, when you are given a proof, they give you what is called the given. This is what we call your starting information. And then they give us what you want to prove. So that should be what you end with. So these proofs are the exact same. They just wrote them in two different ways. So the first is the two column proof, which that's the one you'll see on your Delta Math a lot. So you always state the given first. So these right here are the given. So it said that C is a midpoint of AD and C is a midpoint of BE. And the reason, it's given. They gave it to us. Now, they then said, given this fact, so proofs, they build off of each other. So it's basically saying, okay, if we know that this is true, that means this is true. So if we know that C is a midpoint of AD, what does that say about this line segment? What does a midpoint do? It splits it into two congruent pieces. So can't we say that AC is congruent to CD? Yeah. Same thing with BC and CE. We can say these two pieces are congruent because C is its midpoint. And that's what they said right here. They said that BC is congruent to EC and AC is congruent to DC. Because they said, okay, if we know that these are midpoints, that means we can say that. Why? Because that's the definition of a midpoint. Now, they then said that angle ACB, so this angle right here, and DCE are congruent. Why does it make sense that without any other information they can say that it's congruent? What type of angles are those two angles? They're vertical, all right? These two angles are vertical angles, which we know all vertical angles are congruent, which if you look, they stated right here. Now if you look at these two triangles. Can I say that these two triangles are congruent now? Do I have enough information to say they're congruent? So look at these two triangles. Do I have enough information to say those two triangles are congruent? Yes or no? Yeah, by what postulate? Side angle side. And that's what they stated right here. They said it's congruent by side angle side. So guys, that's how proofs work. They build off of each other. All right? Put the phone up. A flow proof actually does show the connections. So they gave us our two givens. Then they said because we know that C is a midpoint of BE, we can show, hence the arrow, that BC is congruent to CE because that's the definition of a midpoint. We can then show that since C is a midpoint of AD, that AD is congruent to DC because that's also the definition of a midpoint. Now, this doesn't connect to the givens at all, but it's a separate statement. If angle ACB and CED are congruent, because we know they're vertical. All right. Thus, We have a side, and an angle in the order of side, angle, side. So that's why we can show the triangles are congruent. So flow proofs are nice because you can actually see where all the connections are. Two column proofs I like just because you can, it doesn't really matter the order that you put stuff in. It's more just an organizational thing. You don't have to worry about what connects to what. So let's try some. So this is where you're going to want that blue sheet out from last Friday, that blue graphic organizer, and look at your geometric proofs and reasons on the back. So this is one where they gave you the statements. You got to come up with the reasons why it's true. So always, here's what I tell my students, always look at what's given and mark what they give you. All right. So they told us that angle H is congruent to angle E. They also said that UR is congruent to US. And they want us to show that HR is congruent to SC. So they want us to show this. So that should be our last statement. Whatever they want you to prove, that's always your last statement. Now, what it looks like they did is they proved a congruent triangle because then they can show that any two sides of said triangles are congruent by CP/CTC. So first off, angle H is congruent to angle E. Why can we say those are congruent? Why can we say that these two angles are congruent? It's actually staring you in the face. It's given. If they give it to us, that's a reason. They openly gave us this information, and we accepted it with open arms. It was given to us. So, UR congruent to US. Why can we say that? It was given to us. Now, this next one. HUR. So HUR, so this angle right here, oops, is congruent to EUS. So this angle right here. Now, that wasn't in the given information, but we can still say that's true. Why? Vertical angles are congruent because they're vertical angles and they're congruent. So they then said that triangle RHU and SEU are congruent by what postulates? What are those 5 postulates on the other side of that blue sheet tells us that those two triangles are congruent? Say it again. Angle, angle, side. Good. Because we have 2 angles and a side, and that side is not between the 2 angles. Now, we can then say, because we know these triangles are congruent, doesn't that make sense that these 2 sides are congruent? Because we know the triangles are? Yeah. And what reason is that? It's an acronym. I already said it earlier. CP/CTC. Corresponding parts of congruent triangles are congruent. All right. Now, let's try another one. This time, they didn't give us anything except for what was in the givens. So they said that angle UQA is congruent to DQA. So UQA, so this angle, is congruent to DQA, so this angle. They also said that angle DAQ, so this angle, is congruent to UAQ, so this angle. And they want us to show that angle U is congruent to angle D. So they want us to show that these two angles are congruent. So guys, if you ever see triangles and they're asking to show that pieces of triangles are congruent, you prove the triangles are congruent first. Because then you can say any corresponding part of them are congruent by CP/CTC. Now, for these first two statements, they gave us them. So we just say they're given. Because those are the ones they flat out gave us. Now, if I look at this picture, there's one more statement I can make. All right, to show that the triangles are congruent. So I either need, so look at your postulates. Okay, we have two angles marked. What are your only two postulates that could possibly work to prove those two triangles are congruent? How many postulates have two angles in them that are congruent? ASA and AAS. So we either need to prove that the side in between the two angles is congruent, or one of the two sides not in between the two angles is congruent. Which one would make the most sense to show? So we either need to show that this side is congruent because it's between the two angles, or that these two sides or these two sides are congruent. Which one is the only one that we can show congruent based off of what we have? What's a reasonable assumption that we can make? I heard it. QA. So I can say QA is congruent to itself. Why? There's a specific property that says we can do that. The reflexive property. Which is just a fancy way of saying they share a side, so obviously they have to be congruent. Because don't both these triangles share this side? Both these triangles share this side. So now I got enough to say that triangle QDA is congruent to QUA. Why? What postulate? I got two angles and a side, and the side's in between the two angles. So what postulate? Angle, side, angle. Thus, I have enough information to say that this angle is congruent to this angle. So angle U is congruent to angle D. Why? We just proved that the triangles are congruent, so the corresponding sides can be congruent by CP/CTC. CP/CTC stands for corresponding parts of congruent triangles are congruent. Okay, so now here's what we're going to do. Take out your Chromebook, pull up Desmos. We're going to, not Desmos, Delta Math. We're going to do some together. So when you get to Delta Math, I want you guys to go to the one that's labeled 5.2 Intro to Proofs. So 5.2 Intro to Proofs. So we're only going to do a couple of these. Now, guys, don't be freaked out about these. On your test, I will not make you do a full proof. If anything, I'll ask you to fill in the blank. Like, I'll give you a proof with a blank missing, like either for the statement or the reason. You just got to tell me it. All right. So, let's try some of these. So, Delta Math, 5.2 Intro to Proofs. So, we're going to do the very first one together. So that very first section. So, this one is a reasons only. So they told us all the statements. Yeah, intro to proofs. Now, let me tell you something. If it's marked, it is freely given. Okay? So, if I say angle BAC is congruent to angle DCA, so BAC, it's this one tick right here, is congruent to DCA, so this one tick right here. Why can I say those are congruent? They gave it to us, so we can say it's given. They then said that angle D is congruent to angle B. Why can I say that? It's given. Now, this one they didn't give us. It's not marked. But they said AC is congruent to AC. We just talked about this. Why is that true? The reflexive property. Reflexive property. Intro to proofs. 5.2, intro to proofs. Now, they said that these triangles are congruent by what? So we have two angles and a side, and the side's right here. So what postulate is that? What postulate makes these two triangles congruent? It's what? Angle, angle, side. And then we can click submit. So that's how you go about these. All right, but these are easy ones. Let's look at one that may not be as easy. So click the level 2 one. So the next one down. So this time we actually have to come up with the proofs and the reasons. All right. So remember, always start with what they freely marked. And they freely marked two things. They marked these two angles congruent and these two sides congruent. Now, what we want to do is basically put things that we know will connect and things that may not connect. But we're proving this is by angle, angle, side. So they want angle, angle, side. So in other words, we got to show that two other angles are congruent in some shape or form. All right. Now, they also gave us another hint up here. It says given AC bisects angle BCD. So BCD. And what did I say bisect means? Cut in half. So we're going to start by listing this piece of information. So that's going to go in this one right here because it'll connect to something else. So we're going to hit XY bisects some angle X, and we're going to type in what they put, and it's case sensitive, so make sure it's capital letters. So AD bisects BCD. Reason, they gave it to us. It only gives you given as a reason anyway. Now, because we know it bisects that angle, what can we say? So since this line bisects this angle, what can we say about these two baby angles? They're congruent. So we can say that BCA is congruent to DCA. Because why? So first off, let's type it in. So BCA is congruent to DCA. Why? What led us to believe that? So this statement is what led us to believe that. But why does it work? Come on, guys. We said that it bisected the angle. What does a bisector do? It divides into two angles. Isn't there a reason that says exactly that? Yes, that's the one you click. An angle bisector divides an angle into two congruent angles. Now, the other two statements and reasons are easy. We just state what they gave us. So the other two that were marked. So I can say side BA is congruent to side AD. Why? It was given. And I can say that angle BAC is congruent to angle DAC. Why? Again, it's given. Thus, we have the two triangles congruent by angle, angle, side. I know this is a pain in the butt. What did I do? I probably labeled the angles wrong. Oh, I labeled the sides wrong. Okay, that's why. These are labeled wrong. It should be AB is congruent to AD. It's really on delta math is a stickler for corresponding sides. So you gotta make sure everything corresponds. BAC, DAC, no, that's right. No, that's correct. I typed that. It shouldn't matter. Oh, yeah. Yeah. So you got to put the angle first and then the side. So put the angle first and then the side. So just type this. I'll count it. If you got it wrong and it says it stays wrong, I'll count it. This is why I hate flowchart proofs. Okay. So go with the next one down. So, given this shape, we know that these two are parallel. All right. And just to know, it says quadrilateral properties are not permitted in this proof, so we can't say it's a parallelogram. So they said that these two sides are parallel. Here's what I like about the two column proofs in delta math. If you hover over the statement, it'll actually highlight what it wants for you. And they want us to show that these two angles are congruent. So I would say start by proving congruent triangles. So what is one thing, a side or angle, that I can absolutely positively say is congruent? I don't know that AB and DC are congruent because they said we can't use quadrilateral properties. AC and what? Right. So we can say that AC is congruent to itself. Why? Reflexive property. Now, think about why they would tell us sides are parallel. So look at that blue sheet that I gave you. Why would they tell us that sides are parallel? What properties would they may want us to use? So look at the back side of the geometric proofs and reasons. Why would they tell us sides are parallel? Can't we find some congruent angles from parallel sides? Parallel lines cut by a transversal? So what two angles can I say are congruent because of parallel lines? Think about it. If I stretch these sides out, and this is a transversal, couldn't I say that these two baby angles here and here are congruent? Yes, no, maybe? Why? So BCA is congruent to DAC. Why? Has to do with parallel lines. So look at your reasons. Look at all the parallel lines. It's these two angles. So here and here. They're congruent because they are what type of angles? I'll give you a hint. AI. Alternate interior angles. So we scroll down where it says parallel lines cut by a transversal form congruent alternate interior angles. Now, because of that, we can also say that these two baby angles are also congruent. So we can say BAC is congruent to DCA by the same reason. They're alternate interior angles. Now, do I have enough to show that those two triangles are congruent? So do I have enough information marked to show that these two triangles are congruent? Yeah, I do. So I can now state that BAC, and since I went to the non-marked to the purple to the green. So I gotta do the same thing. I go to the non-marked, so D to the purple, C, green, A. Make sure you match up corresponding parts or we're counting wrong. And why are they congruent? By what postulate? What's the postulate? Angle, side, angle. Good. Now, remember what I said. If you prove triangles are congruent, you can always prove that angles within them are congruent by what? So angle B is congruent to angle D by what postulate? CPCTC. Corresponding parts of congruent triangles are congruent. And the nice thing about these is that you have to try them each time. Otherwise, and it won't count it wrong if you don't put in the correct statements. And there's really no correct order. I could have listed either one of these three things before each other. All right. Let's try quadrilateral proof. So go to the first one that says quadrilateral proof, missing step. So they said given ABCD is a parallelogram and AEFD is a rectangle, prove triangle ABE is congruent to DCF. So they already did pretty much all the work except for one statement. So we just got to go through and look to see what's missing. So we know that this shape right here is a parallelogram. All right, so ABCD, so this shape right here is a parallelogram, and AEFD is a rectangle, meaning all their properties apply, since we know that they are those shapes. They then say that EC is perpendicular to FD. Why can I say that EC is perpendicular to FD? What do we know about rectangles? Rectangles have 4 right angles, so perpendicular means they intersect at a right angle. So that means if this is a right angle, these have to be perpendicular. Thus, DFC, so this angle right here, is a right angle. They say angle E is a right angle because that is part of the rectangle. And rectangles have 90-degree angles. They then said that ABE is a right triangle. Why is it a right triangle? It has a right angle. They say that this triangle is a right triangle because it has a right angle. They say that these two sides are congruent. Why? Because they're the opposite sides of a rectangle. Now, they're saying they're proving by hypotenuse leg that the triangles are congruent by hypotenuse leg, which we can because it's a right triangle. They gave us one side. Is that the hypotenuse or the leg? Those are legs. So what do we need? Hypotenuse. Which two sides are my hypotenuse? AB, and CD. Can I say that they're congruent? Why can I say that these two sides are congruent? So AB and DC. There's something that we stated earlier that lets us do that. What? I'll give you a hint. It's in the givens. We can say that these two sides are congruent because they are what to each other? They're what? What they say ABCD was? A parallelogram. Aren't these opposite sides of a parallelogram? And don't we know that opposite sides of a parallelogram are congruent? That's why we can say that they're congruent. It was already stated it's a parallelogram, so all of its properties apply. So BA and CD, why? Opposite sides of a parallelogram are congruent. So guys, these are all logic. They're a pain in the butt, but they're logic. But you gotta think about it. Like, I know they're hard, but you just have to think about it. You just have to go through everything and be like, okay, well, what's missing? All right, let's try one where they just gave us all the reasons, or they gave us all the statements, but we need to put the reasons. All right, so they said that this entire shape was a parallelogram. That's the next one down. So they said that that entire shape is a parallelogram. They then said that point E is a midpoint and point F is a midpoint. So they said that AD is congruent to CB. Why are those two sides congruent? What up here tells us that these two sides are congruent? What in our givens tell us that those two sides are congruent? ABCD is a parallelogram, and what are those two sides? Well, they're not parallel, they're congruent because they are. What's true about a parallelogram and its sides? Opposite sides are congruent. So the opposite sides of a parallelogram are congruent. That's why those are congruent. They then say that DC is congruent to AB. Why? Look at where they are. Why are they congruent? What previously told us that those can be congruent? Come on, guys, just take a shot in the dark. It's probably what you think it is. I probably just scared you too much. Just take a shot in the dark. I know proofs are a pain in the butt. I struggle with them sometimes. Just go for it. Why are those sides congruent? Because they're part of a what? A parallelogram. And aren't they opposite sides of a parallelogram? Yes, so they are congruent because we know that it's a parallelogram. They say that FC is 1/2 of DC. So they said that FC is half the length of DC. Why is that true? What did they say earlier up here that would lead us to that fact? F is a midpoint. So the reason that FC is half of DC is because a midpoint, so you look for where it says midpoint, divides a segment into two parts, and each part is half the length of the whole. So AE is equal to half of AB. Why? So AE is here. AB is the whole. It's the same thing. E is the midpoint. So we use the same statements. So guys, you'll find that a lot of these statements repeat. So they then say that FC is equal to AE. Why can I say that? And it just cut out. So why can I say that these two sides are equal? Think about it. Then they're bigger. Aren't they half of congruent sides? They're both half of congruent sides, right? So would that make sense that if they're half of two congruent sides or sides that are of the same length, that they would be equal to each other? Yes. And there should be a reason just like that. So it is segments that are half the lengths of congruent segments are congruent. Now, they then said that those two angles are congruent. Why? They're what? Well, they're not right. They're part of a shape, though. Well, they're part of triangles, but what big shape tells us that those two angles will always be congruent? Parallelogram. They're opposite angles of a parallelogram, which we know are congruent. Thus, these two triangles are congruent by what postulate? Side angle side. So these two sides have to be congruent. Why? CPCTC. Good. And that's it. So, guys, sometimes the statements are harder to come up than the reasons. The reasons you just have to think about, okay, what property tells me that this is true? What did I use, or like what statement did I say previously that makes this statement true? If you noticed, a lot of these statements came from the fact that ABCD was a parallelogram. All right. A lot of the reasons for these statements came from the fact that ABCD was a parallelogram. All right. Two of the statements came from the fact that E and F were midpoints. All right. So that's how these work. All right. Now let's try if we can see if we do one by ourselves. Well, I'm not going to have you guys do it by yourselves, but we're going to work through one where we have to do the whole thing. So go to the next one. All right. So it says ABCD is a rhombus. So that's a rhombus. They also said that these two segments are equal and these two segments are equal. And they want us to prove that these two triangles are equal. This is actually really easy. What do we know about rhombus? What do we know about a rhombus? It has four congruent sides. So let's think about it. If I want to show that these two triangles are congruent, couldn't I say that there's something else that's congruent? So I already have two sides that are congruent. Isn't there a postulate that has, you can say two triangles are congruent by all three sides? Yes, no, maybe? Yeah, there is. So, and we know that this entire shape right here is a rhombus. So what can I say? Which side specifically of this rhombus would make the most sense for me to say is congruent? AD is congruent to DC. Why? Because all the sides of a rhombus are congruent. So all sides of rhombus or square are congruent. So now do I have enough information to say these two triangles are congruent? Yes. So triangle, and you can just copy what's up here. ADE is congruent to CDF by what postulates? What's the only thing I got marked here? Side. So it has to be side, side, side. And that's it. That was only a 3-statement proof because they gave us a whole lot of information. All right, let's try another one. Shh, 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 shh. All right. ABCD is a square. All right. And they want us to prove that triangle ABE, so this triangle right here, is congruent to CBE, so this triangle right here. So let's go with what we know. What do we definitely know about a square? All sides are equal, 90-degree angles. All right, so let's stick with the all sides are equal fact. What's a side? What are the two sides of these triangles that we know for a fact are equal? AB and BC, because they're part of the outside of the square. So that's what we say. AB is congruent to BC because all sides of a square are congruent. Now, what else do we know about a square? Specifically, think about diagonals. What's true about a square's diagonals? They're perpendicular. So couldn't I say that? Well, first I gotta say that they're perpendicular. So I'm gonna use the perpendicular. And I'm gonna say that AC is congruent to BD. Not congruent, perpendicular to BD. Why? Because that's just true in a square. Where is it? Consecutive. That's not true. The diagonals of a rhombus are a square perpendicular. There it is. Now, the reason I have to say that is because they're picky. And even though we know that they're perpendicular, they still want us to say it. All right. Now we can say that these two angles are right angles. So I'm going to say angle AEB is a right angle. Why? Because perpendicular lines form right angles. I'm going to say the same thing for CEB. Now, why would I care that they're right angles? Why would I care? What does that make the triangles? What does that make these two triangles? They're what type of triangles? They're right triangles. And what postulate could we possibly use to prove that two right triangles are congruent? Hypotenuse leg. All right. And don't we already have the hypotenuse congruent? Yes. So I'm going to go ahead and classify both these triangles. So I'm going to say that AEB is a right triangle because it contains a right angle. I'm going to say the same thing for CEB. Now, isn't there another side that I can say is congruent in these two triangles? I got the hypotenuse, now I need the leg. Is there a leg of these two that I can absolutely say is congruent without a doubt? What? BE. Why? Can I say that BE is congruent to itself because they share it? What's that property? Reflexive. So now I got enough information to say that these two triangles are congruent by hypotenuse leg. So AEB is congruent to CEB by hypotenuse leg. Now, if you ever have to use hypotenuse leg, you have to state the triangles are right triangles. Otherwise, they'll count it wrong or whatever because they're picky. All right. So I'll give you all a break. Okay, so I will give you guys credit for this delta math because we've been working through it together. But the other one, the quadrilateral proof one, it's really short. I didn't give you a whole lot, and it's only stating reasons. All right. So, hush. Let me get through this. So, your assignment is the 5.2 quadrilateral proofs. All right. Now, 5.2 intro to proofs. I will give you guys a participation grade because that's what we did together in class. But this one you got to do on your own. It's short. It's only, if you look, there's a couple of coordinates, but it's mostly just reasons. All right. Go ahead. All right, guys, make sure your whiteboards are